Hey there, Russ here. Welcome back to the shop. Okay, let's do a two-part video here. I'm going to introduce you to my version of a 12-volt Ryobi battery charger. Yes, Ryobi makes one. And you might ask, well, why would you even want to? Well, first off, this thing only cost me $17 to make. And if you look at theirs, probably, I think the going market right now is around 50 bucks. So anyway, it is cheaper to make it by far. Also, instead of idiot lights, I actually use a voltmeter and an amp meter. So you know exactly what kind of charge is going in there and your state of charge as you're kind of going along by monitoring it with the gauge unit instead. So I actually like this a lot better. If you ever really looked at their unit, now this is a plastic case with a 12-volt plug-in. So where do you think this thing is going to get used? It's going to be thrown in a work truck and just bounced around, thrown from drawer to drawer and knocked off the shelf, and I can just see that thing not surviving very well. This thing is really very durable. The cord is anchored down to protect it, and you can just throw this around and it should be fine. It should last a lot better than that one they have, and it's much more compact. To use it is really very simple. I have two batteries here. One's a fully charged battery, and one's a very low battery. And when you put it on there, we watch the amp meter. Between the voltmeter and the amp meter, you know what the state of charge of that battery is. And when it gets close to being fully charged, if you don't want to wait till it's fully charged, you don't have to. You can go by just the voltage, pull it off of there later on, and be able to start using that battery even if it's not fully charged. And you'll know about what to expect out of that battery based on the voltage that's in it. So the gauge is a lot more accurate than those lights that they put on theirs. The main thing is the durability of this thing compared to theirs. That just scares me to death to think about that thing's trying to survive in a work truck. So let's take a quick look at how it works. It has a cord that plugs into any cigarette lighter out there. So it has a fuse built into the this part here, so it's circuit protecting. I have it anchored here so that it isn't going to get pulled out accidentally while you're using it or having it up somewhere in your truck. When it's not in use, you can wrap it up on the Velcro, and it holds it pretty durably right there. Now this has a little fan I put on it so that, and this is the air intake for that fan. The box itself is kind of pretty well sealed. So any air going in, any air that is sucking from here, it also draws air in here. And this happens to be real close to where this boost connector is, which is the hottest component of this whole unit. So the air has a heat sink on it, and it dissipates the heat off of the board itself. And this draws the air from the box, and this brings fresh air into the box, and that has to go pretty closely right across that circuit board. So it's going to keep it reasonably cool, and it does seem to stay pretty cool. I've used this a few times testing it, and the amount of heat that you can feel coming out of there is very minimum. So I think that the way I have it set up, this thing should not have an overheating problem, because when it comes to charging, you need lots of ventilation, and you need to make sure it doesn't overheat. So on this unit, with the fan, it just help protect this thing from actually coming apart. As far as taking it apart, it has 4 screws on this top panel. The voltmeter and the fan are attached to this part. It has long wire leads on it, so it comes off for quite a ways. Or you can take the 4 screws out of the bottom, and then the receptacle, which is attached to this bottom plate, along with all the other electrical components, you can pop that out and work on it on your bench without any problem to diagnose it if you have a problem or something you want to take a look at. So let's take a quick look at how it works, and then I'll pop the bottom off of it so you can kind of see where it's going. And that should be pretty close to the end. Oh, one more quick thing. This thing does not do something that a normal battery charger does. And that is that some batteries have this status gauge on it. Like that. This is a 4-bar system. The communication between this circuitry right here and the battery charging is not done through the regular two battery terminals, the positive and negative. You have to have this connected also in order for it to communicate with the battery. And I think this is legacy stuff from years ago when they had the Nikon batteries instead, NiCad. But they still use that circuitry, unfortunately. So when you charge it on this, you'll be able to tell the status by the voltmeter, but you will not know from this. It does not update this gauge. So if it reads only 2 bars on it, it can still be fully charged from this, and it'll still read 2 bars. If you want to update that, you have to plug it into a regular factory charger for a few seconds, and it'll update that gauge without any problem. So if it's fully charged and it's reading 1, you get back to the shop, you plug them in overnight. It's probably not a bad thing. Let them charge up slowly back to a full charge, and you're better off. So when you're out in the field, though, you can just charge it up to a certain voltage and grab it and keep going so that you can continue using your tools if you're running low on batteries with a charge in them. To use it, you just simply drop the receptacle onto the battery like so, and you should be able to read the voltage. Now this is the low battery, only 1 bar, and as you can see there's 17.8 volts. No amps because it's not plugged into the charging source so that it can draw the volts to charge it. So all we're doing now is just reading the battery voltage of the battery itself. And at 17.8, that tells me normally if it's around 20 volts or above, that battery is pretty close to fully charged. When it gets down to 17, under 18 volts, that battery is getting close to being fully discharged. In order to charge it up, I just so happens I do have a cigarette lighter plug-in here in the shop, which saves us from having to take this all out to my car and do this thing in the front seat of my car. That would be a little crowded for all of us. So I have this set up, and when I plug this in, the light goes on my unit, on this unit here, and now I'm getting a charge on this, and the voltage is starting to slowly go up. And if you watch, the amp meter is slowly dropping off. Right now it's charging 3.2 amps or a little less, dropping down, and the voltage will be going up as time goes on. Once it reaches fully charged, then the amp meter will read 000. This is a fully charged one. So if I put this on here, you can see it says 20.2. Now when I plug it in, it'll probably show amps charging at this point, and then when it reaches 2.9 volts, then this will go to 0, and that tells me that it's fully charged then, because once this reaches full zeros, you can leave it plugged in if you want. I would not. I just don't think that that's a good idea to ever leave batteries. Not even in the Ryobi ones, I don't like to leave them plugged in. But eventually, you'll know it's fully charged when it gets there. That fan's already got a little buzzing sound to it. Anyway, you can hear the fan going. The fan runs only when it's plugged in to a battery source. When you plug this on here, you can read the voltage, and this is the true voltage of the battery. If you plug this in here, then you're not reading the true voltage of that battery necessarily. It finished charging and turned off, and now the battery's starting to back off again a little bit at 20.7 volts. It'll stay above 20 volts. There it is, 20.3, without it being plugged in. So it's now fully charged. There was no amps going into it. You can take it off and you have a fully charged battery. That's how it really works. It's pretty simple. Instead of idiot lights, you just have to read your 2 gauges and interpret what you're reading to know when it's low state of charge by the voltage on it, or if it's charging or not when it's plugged in by whether or not you're getting any numbers on your amp meter. So that's the whole thing in a nutshell. It works really well. So let's take a look at what this thing looks like on the inside and how it's made, so that if you've done stuff like this before, in the next few minutes you'll have all the information that you need to build your own. The box, it's about 6 inches by 4 1/4 by 2 1/2. This measurement is 1 1/2 inches, and this degree angle here is 22.5 degrees. So if you follow those dimensions right there, you'll be able to make this box. The box is made of a regular box. This is the plate here, has the receptacle and all the electrical components attached to this bottom plate. So when I take these 4 screws out, you'll see that it comes out, and most of the electrical stuff will come out with it. At the same time, the 2 other components that you don't see, the voltmeter and the fan, you take this loose and you have access to that. Or if you don't want to pull the bottom off, you can pull this out and you get pretty good access to most of the electrical in there without any problem. So it is very easy for you to take apart at this point. What else was it I wanted to do with this? Oh, we're going to go over the electrical. So anyway, so in order for this thing to work, there's 6 components you need. You need the cigarette lighter plug-in, you need the fan, you need a volt amp meter, you need a booster, a boost converter, and you need that little battery clip that clips onto this that all receptacles has, and it's up in there. So when I plug this in, those 2 connect to the positive negative on the Ryobi battery. That clip is a special part. I'll leave all the link to all these pieces of where I got these in the description, so you'll be able to buy these. Now, also in the next video, I'll explain to you about the gauge on this thing, and how to, if you wanted to update this thing does not update it. If you wanted to, I'll explain to you how you can set that up and add that feature to your battery charger so that it would update those. I would have done it that way myself, be honest with you, except I only yesterday did I finally learn how to get this thing to actually work properly with that. And it takes a special size resistor that you have to use. So, and I'll get into those details in the second one if you need to go there, or if you want to know about that. But I think that's the whole thing in a nutshell. As far as the wiring diagram, you have your plug-in here, and then on these 2 wires coming from your source to your booster, to your boost converter, I do tap into those 2 wires, positive and negative, for the 12-volt fan. So when it's plugged in, there's power on these cords and the fan runs. So if it's not plugged in here, that fan does not run, but it doesn't need to. The boost converter has 12 volts going into it, the same as any vehicle out there. And coming out, I've adjusted the boost converter to 20.9 volts, which is pretty close to the full state of charge for a Ryobi battery. The exact one you want to use, that would be up to you. You could theoretically set it to like 20.3 volts so that it would only charge these up to 80% when you're out in the field every time. That way you can save the slow trickle charging at topping off these batteries on a regular charger without any problem, because those are a little more sophisticated chargers. This thing will pump an amp or more at all times into this battery to charge it up. So it's more like a fast charger type of thing. And if you do that with lithium batteries, they say that hard charging it all the way to 100% will shorten the life. But if you're only going to 80%, that's not a problem. So you can set that to, if you want to make your batteries last longer, you can adjust that on these chargers so that you can either do a quick 80-90% charge or get a full charge out of it if that's what you want to do. Do your research on that and decide how you want to handle that. I have mine set at 20.9. I don't use a fuel gauge. Everything was just fine with me, and I'm comfortable with using it this way. So once it goes through this boost converter, everything here is 20.9 volts then. The meter side, the positive comes over and goes to the positive of the battery. The negative side of the booster comes over here to the negative side of the battery. Now, the voltmeter is tapped in to the positive wire here. This 29 volts from the booster to the battery, it taps in so that the voltmeter will read what the voltage is going on the 18 volt side, how many volts there are. The amp meter has 2 wires coming out of it, a red and a black, The black goes up to the negative on the boost converter, and the red one goes down to the negative on the battery. So this is hooked, the amp meter is hooked in series on the negatives of the booster to the battery. And it's that simple. I mean, if you know how to do one of these, this is no big deal. But that's the wiring diagram that I used to make this here. Everything works fine. Battery work, the fan works when it's supposed to. It does not seem to overheat, and I think that a lot of that has to do with having the fan and the heat sink on here. So if you take a look at the booster, this is the one, I burnt this one up, so this one's bad. But right on top of this chip, I put a little heat sink on there, and that really helped keep this a lot cooler. The heat sink is optional. I don't have any, I had these already. I got them with some other thing, so I can't really guide you on that. But it's like 3/8 of an inch by 3/8 of an inch heat sink with a sticky back on it. So you just peel it and stick it down. You can buy them out there anywhere. Just do heat sink on Amazon, and you'll find a whole wide selection. You can get a little bundle of different sizes and that. Do what you need to do there. So let's take this lid off so that we can finish this up. So if I take the 4 screws out of the top panel, you can see inside this thing. And then we'll call this video done. And there we go. So now you can see all the wiring that's down in here. There's the boost converter. That right there where my index finger is, that's the heat sink. These are the little holes on the side for the air intake in there. These are just little lever connectors, so it helps me keep the wiring under management, so I can connect and disconnect the different components if I want from the system and replace them. There is no real soldering done on this unit here, except that when you get your boost converter, you do have to solder leads on all 4 connections, the positive negative in and a positive negative out. You do have to solder on lead wires in order to connect everything up. If you can't do soldering, then you don't want to use this type of boost converter. And they make some of those where you have the screw down, where you use the screw and tighten it down. You can look for what you want. If you can't solder, and you could probably use something like that, that's up to you. I just soldered them up, and that's the only soldering that I did. Everything else is pretty much just wire connectors, using those lever action type connectors. I think that's it in a nutshell. That's how it works. That's why I made it, and why I think it's better than the Ryobi one that's out there. If you want, watch video number 2 on this. I'll have it come out probably yet today, in the morning at the latest, and we will go over the insides of this. I'll finish taking this apart. We'll get a close look at everything, because I know, Mark, you wanted me to do that, and I will take a close look at all this. We'll talk about why I picked certain things the way I did, and how this thing actually comes together the way it does. So you'll get more details on once we take it further apart. So stay tuned for part 2. I don't know if it'll be longer or shorter than this video, but this one at least gives you the essence of what you need and why you need it in order to build this particular unit if you want to. I don't remember if I told you. Did I tell you the measurements of the box? It's 1.5 inches here. It's 2.5 inches here. The box just sits down on this plate. This box is 6 by 4 by 2.5. This angle right here is 22.5 degrees. So that's all you need to know, and then you can make this box. If you have any questions or want more detail in that, watch the other video and ask questions once you've looked at that. So thanks for stopping by. I hope you like this. Leave your comments and ideas. If you know something about this charging gauge here that enlighten me about it, let me know, because I'm still trying to figure some of that out. But right now, everything does work. Thank you for stopping by. If you like this video, you learned something here, hit that like button. Most importantly, though, please come back again because, quite honestly, I'm nowhere near done. Thanks. We'll see you guys again soon.